Clear? Clear? So what is rate of change of area with respect to time is always constant. Now it's already derived. So no need to remember the statement. You already know mathematical relation now. And you also know how to drive it. I already derived all step. Yes or no? Tell me. Clear? 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 Yes or no? Yes or no? Tell me. Yes or no? All the steps are clear. Yes or no? Tell me. Tell me. Tell me. Clear? So DA rate of change of area with respect to time is constant. The aerial velocity of the planet is aerial velocity, not velocity. Clear? Aerial velocity. Clear? Angular momentum is constant. So two different positions. So if you see velocity is inversely proportional to r. So I r if the planet okay is close to sun, speed will be I. Velocity is inversely proportional to radius. Clear? Clear because L is constant. Okay, clear? 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 So question, is the speed of the earth more at perihelion than at aphelion? Perihelion is shortest, closest. Clear? 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 So shortest, so radius is shortest, so speed will be high. Clear? Clear? So at aphelion, speed will be comparatively lesser. Clear? Tell me. Clear? 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 Which law states the line joining the sun and the earth sweeps out equal areas equal interval of time? Kepler's first law? Not at all. Kepler's second law? It seems. Yes or no? Third law? No. Gravitation? No. So answer is Kepler's second law. Clear? Clear? Radius vectors drawn from the sun to any planet sweeps out equal areas equal interval of time. Clear? 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 Tell me. Clear? Clear? So motion of planet in the solar system is an example of conservation of mass. Eh? Not at all. Not at all. Linear momentum? No. Angular momentum seems energy. So motion of planet solar system is example of conservation of angular momentum. Clear? Clear? We already tried now. Clear? 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 So last law. T square is proportional to R cube. Kepler's third law. Clear? Clear? T square is proportional. Okay. R clear means T1 by T2. If you put a square here equals to R1 by R2. Clear? 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 Any dot? Ask me. Any dot? Ask me. Clear? 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 Third law is complete now. It's over. Yes or no? Tell me. Tell me. Tell me. Tell me. So Kepler's third law is also known as law of periods because we are talking about time. The square of time for a planet to complete one revolution around the sun is directly proportional to the cube of the semi-major axis of the elliptical orbit. What is R? Semi-major axis of the elliptical orbit. Clear? 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 T square is proportional to R cube. Means T square by R cube is constant. Clear? R is the semi-major axis of elliptical orbit. Clear? 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 Now suppose capital T is the time taken by the planet to complete one complete revolution. See, capital T. In capital T time, Earth is revolving around the sun. Clear? So when the Earth is near to sun, and when the Earth is far to sun. Clear? 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 So here R is the semi-major axis. So T square is proportional to R cube. So this relation will be valid for two different interplanet. Okay, if you know the time period for revolution for one planet, you can find out time period for revolution for another planet. If you know their semi-major axis, clear? Tell me. Clear? Clear? So this law is also known as the harmonic law or law of period. This is harmonic in nature. Law is happening. Everything is happening harmonic in nature. So law of period. So any question can come from here. Okay. So you should take care of all this. Clear? So according to our law of capacity square is R square. This is wrong. Clear? Which one is correct? Which one is correct? This is wrong. This is wrong. This is wrong. This is correct. Clear? 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 Any doubt to anyone up to here? Tell me. Tell me. Tell me. Any doubt to anyone up to here? Tell me. Tell me. One more question. According to Kepler, a satellite always revolves in a circular orbit, elliptical orbit, parabolic orbit, hyperbolic orbit. You know. Clear? 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 So today we keep here. So take care of all the points what I discussed. All the points are very important. Questions comes directly in your examination.